So now we are going to study about a new term which is called capacitance. And capacitance is it's a property of a capacitor. Okay, and suppose that if you have any plate, metallic plate, and there's another metallic plate, and if it is positively charged and if this plate is negatively charged, it has a charge of plus Q, it has a minus Q charge, and the potential difference between these two plates is delta V, then this is called a capacitor. Okay, so it just means that if you have two plates and they are kept parallel to each other and one plate is positively charged and the other is negatively charged, it makes a capacitor. Okay. Now this charge, it depends on the potential. Now what is the meaning of delta V? It means that suppose if this plate is at potential V1, this plate is at potential V2, so delta V will mean V2 minus V1. And so this charge, it depends on the potential difference. If the potential difference is large, you will have larger charge, and if it is smaller, you will have smaller charge. So it means the charge is proportional to change in potential difference, and therefore Q will be equal to a constant into change in potential. This constant is a C, which is Q upon delta V, and this C is called the capacitance of a capacitor. This term capacitance is taken from capacity. Okay, how much a capacity to store charge, how much capacity a parallel plate capacitor or any other capacitor has to store charge. Capacitor to store charge. So if you have two conductors and it is a conductor, okay, and this is also a conductor, so both of these plates, they are conductors. Now how this works, how the charging of the plates is done. So now suppose that you have a plate. Let us try to understand this charging phenomena. And these plates, they are attached to a battery. Okay, suppose this is the arrangement now. These are two plates and they are metallic plates and they are attached to a battery. And battery is such that, you know, this side will be negative and this side will be the positive terminal of the battery. Suppose here the potential is V1, here the potential is V2. So the potential difference at the battery will be V2 minus V1. Now initially we don't have, so this is your initial situation. Okay, the charge on the plates is 0. Okay, and the potential here is 0 and potential here is 0. Okay, so then because there is a potential difference, here you have no potential, no charge, while here you have a potential. Now if you pay attention to this part of this figure, this, okay, then this is a metallic wire. It is just a metallic wire. It might be copper or aluminium, but usually we use copper. Okay, so it is a metallic wire, and this, it's also a metal, a conductor, or we can also say a metal. Okay, so this is one piece of a conductor from here to here. So this whole, it is a one piece of conductor. So you know, in a conductor, I hope you remember that if a conductor is attached to another conductor, okay, so if potential is V here, it will be V here, it will be V here. if you have any conductor, suppose you have this conductor, so if it is potential V here, it will be V here as well. So if it is one piece of conductor, the potential will try to become same. Okay, so how is that achieved in this case? So now it is at a higher potential, which is negative potential, so it will give away an electron. Okay, and this electron will travel to this plate. So when one electron reaches here, it will have a charge of 1e negative, and in response to this charge, one electron will leave this plate and it will have a charge of plus 1e. Okay, similarly, now another electron will move towards the plate and it will have another electron here, and it will have a loss of another electron. So now the charge will be 2e negative and it will be plus 2e. Similarly, this will continue until the potential, when the potential here is V1, it will become potential V1 here as well, and it will have some total charge. So what does it mean? It means that after some time, if it has a potential V1, it will also have a potential V1, and when the potentials become same, then no more movement of charge. There will be no more movement of electrons. And suppose for this to achieve this potential, we have a plus q charge here and a minus q charge here. And if the potential at this terminal is V2, it will be V2 also. Okay, because it is one piece of conductor, this whole of this. So this whole will be at the same potential, this. And similarly, this is also one piece of conductor. So it will also be at one potential. So it will be V2 and V2. Okay. So this will happen in some seconds, in some nanoseconds, that you start from charge 0 and it will acquire some charge. Start from potential 0, it will acquire some potential V1. Okay. So finally, there will be a potential difference of delta V between these two plates, and if it is a plus q charge here, it will be minus q charge here. If it is V1 here and V2 here. So this will happen in a fraction of seconds. Okay, and this whole process is called charging of a capacitor. Now, this capacitor, it has very typical characteristics, and sometimes it is difficult to understand. Okay, so let me just explain it to you again, that if you have a plate and it's attached to a battery, then initially it is V1, it is V2, and potential is 0, charge is 0. Okay, so initially the charge is 0, the charge is 0. Okay, and then let me just denote this by these two plates. Okay, so they mean this means I'm talking about a capacitor, these parallel plates. So let me just use a switch here. Okay, so these are two switches. So if the switches are closed, then suppose it's negative and it's positive, we gain a minus q charge, we gain plus q charge, and it will gain a potential of V1, it will gain a potential of V2. And these two switches, they are closed at this point, so that the circuit is complete. Okay, now suppose that this is completely charged. Okay, this capacitor is completely charged and it has a charge of minus q, it has a charge of plus q, and V1 and V2. So you know the potential difference between these two will be delta V. And now you open these switches. Okay, you open the switch, and so it means that the capacitor is disconnected from the battery. So when it is disconnected from the battery, now suppose you attach this capacitor to something else. Let us say you are attaching it to a bulb. Okay, and so you close the switch and this bulb will light. Okay, so this charge, it will flow again from here to here. So it will lose this negative charge and it will lose the positive charge, and after some time you will again have a zero charge here. So here charge will be 0 and here also the charge will be 0. Okay, and the bulb, it will stop glowing. Okay, so what does this mean? Let us revise it. It means that first you have these parallel plates and they have a charge of 0 and you attach it to some battery. Due to this potential difference, because it is a conductor, it wants to have a same potential everywhere. So if it is V1, it will be V1, it is V2, it is V2. Okay, so you can attach two switches here so that you can close it and open it. So suppose now it is attached to this battery, it will acquire a charge of minus q, plus q, potential V1, potential V2. Okay, so now suppose that now you remove this capacitor, you open these switches and you remove this capacitor and you attach this capacitor to a bulb. Okay, so when you attach this capacitor to a bulb, you know it has some charge, so this charge will flow through this bulb and this bulb will glow, and this capacitor will act like a battery. But after some time it will lose its charge, yeah, because the negative, from the negative charge the electrons will flow, enter the bulb, and they will go to the positive plate. So the charge will decrease with time, and so at last the charge will be 0 on the plates and the bulb will stop glowing. So this, from going from charge 0 to some charge, this is called charging of a capacitor. And then going from charge to 0 charge, this is called discharging of capacitor. Okay. Now let's talk about the units of a capacitor. Now we have defined capacitance to be charge per unit volume. Okay, and capacitance has a units of farads. So 1 farad will be equal to 1 coulomb divided by 1 volts. But farad is a very large unit. We usually don't use this. We usually use a microfarad. So it will be 1 into 10 to the power minus 6 farad. Or we use a picofarad, which is 1 into 10 to the power minus 12 farad. Okay, that's all.